What's up? I'm Vin, and today I want to go through the June 2023 Algebra 1 Regents, and I'm going to do parts 2, 3, and 4. I'll leave a link to a copy of these questions in the description below. And first up here, we have part 2 questions, and they're worth 2 credits each. So we're starting with question 25, and we have to solve this equation algebraically for x. Now, just know, let's say you want to use a calculator for this. You would only get 1 out of 2 points, which is better than getting 0. So if you have no idea what to do, just use a calculator. But if we want full credit, we're going to take the negative 2.4, and we're going to distribute. So we have negative 2.4 times x, and then we have negative 2.4 times positive 1.4, and that's going to work out to a negative 3.36. And now this is equal to, we have 6.8x and then minus 22.68. So now the goal here is to get the x's on one side. So I'm going to move the negative 2.4 to the right because I would rather be working with positive numbers here. So I'm going to have plus 2.4x like this, and I have to do that to the right side as well. And on the left side, this is going to cancel out. We have these terms canceling, and we're left with just negative 3.36 equals. And now if we add these two terms together here, this we could just do by hand. If we have 8 plus 4 is 2, we carry the 1, and then 1 plus 6 plus 2 is 9. So we have 9.2x, and then we have minus 22.68. So now we're going to add the 22.68 to both sides because our goal is, once again, we want to solve for x. So we want to move everything away from x. So now I'm going to have to add 22.68 to this side as well. And for this part here, you could use a calculator for this. Just do 22.68 minus this, or do negative 3.36 plus this. And that's going to work out to 19.32. And then you have equals 9.2x like this. And now to solve for x, we just divide both sides by 9.2. And if we do the division in a calculator here, x is going to equal 2.1. And here's our solution to question 25. Now let's check our answer here. We could press math and press up and go to numeric solver here, option C. And we type the left side of the equation, and we have negative 2.4, and we throw on the parentheses, and we have x plus 1.4. And then we're going to write the right side of the equation on E2 over here. So we have 6.8x. So we have 6.8x and then minus 22.68. So we'll just see that we did this correct here. And now we press graph to press OK. And then this, we just press solve. We're going to press solve by just pressing graph like this. And it tells us our solution x equals 2.1, which matches what we have. Question 26, we have a graph of f of x, and we want to state the zeros of f of x, and then we want to explain our reasoning. So the zeros of f of x are the points where the graph crosses the x-axis. So these are the x-intercepts here. But we just have to identify the x values, and this is going to occur at x equals negative 2, at x equals positive 2, and at x equals 3. So we could say that the zeros occur at x equals, and we have negative 2, positive 2, and positive 3. So we could write this with curly brackets. We could also say, so another way to write this, I'll just write it in terms of a thought bubble here, is we have the zeros occur at x equals negative 2, x equals positive 2, and at x equals 3. So this is also acceptable, but I just like to use curly brackets. And how do we know that these are zeros? Because this is where the graph crosses the x-axis. Question 27, we have Brianna creates the pattern of blocks below in her art class, and a friend tells her that the number of blocks in the pattern is increasing exponentially. We want to answer here, is her friend correct? And we actually have to explain our reasoning. So what I would do here is just count out the number of blocks in each pattern. So for the first one here, there are 4 blocks. And then for the second pattern, there's 6. And then if you count this out, we have 8 blocks. And then finally, we have 10 blocks. So now think about, how is it changing to get from one pattern to the next? What is the change here? Well, to get from 4 to 6, you're adding 2. And then to get from 6 to 8, you're adding 2. And then finally, to get from 8 to 10, you are also adding 2. So when I look at that, the first thing that jumps out at me here is that this is increasing by a constant rate of change. So this would be a linear pattern, not an exponential pattern. So is her friend correct? I would first say no, her friend is not correct. So no, and why not? Because the pattern is increasing with a constant rate of change. Now, before we move on, what would it look like if it was increasing at an exponential rate? That would be if we started with something like 4, and then let's say each time it doubled. We would have 4, then 8, then 16, then 32, and so on like this. So if you multiply by the same number each time, that would be an exponential rate of change. But when you're adding the same number each time, that's linear. So the friend is not correct. So question 28 is all calculator work. We have this set of data here, and we have to construct a box plot. So to get our box plot, we press stat and go to edit, and we're going to enter this data in the L1 column. And now once we have everything written in, we press stat and go over to calculate, and we're going to calculate one variable statistics So we just press enter here and calculate, and we get all the information that we need. So we're just gonna have to scroll down here. This is all the stuff we need. We have the min, Q1, the median, Q3, and the max. So I'll just write this stuff down over here. So this is all the important information we need to construct our box plot. Now I'm going to label all this stuff over here. So the missing numbers, to find them, we're counting 1, 2, 3, 4, 5 spaces to get to 20. So if I did 20 divided by 5, that would be 4. So that tells me to count by 4s, and I have 4, 8, and I'm not going to keep counting like this, but these are the missing numbers that we would need. You just do +4 all the way. You don't actually have to do this for full credit, but I like to do this so that when we actually have to plot these numbers, we know where to go. So we have this, and then we have 44, 48, and then the last two numbers, we have 52, 56, and then +4 brings us to 60. So that's how I know that we plotted this correctly. So now the min occurs at 4. So I'm going to draw a vertical line like this. And then we have Q1 is equal to 18. So that's right between 16 and 20. So I'm going to put that over here like this. So that's the value for Q1. And then the median occurs at 28. So that's right over here. And then we have Q3 is 46. That's between these two, between 44 and 48. So then the max occurs at 56, all the way at the end here. So now the way that you actually construct this is you draw a line like this. And in the past, they used to call these box and whisker plots, because when you would draw this out, the ends here looked like whiskers. So I don't know, they took that phrase out, but I thought it was pretty helpful because you could see like, oh yeah, that kind of looks like whiskers of a cat. So then you have 46, and then the last whisker is going to go from 46 to 56. So just know here that when you're constructing this, this is your min value, and then you have Q1, your median goes here, and then you have Q3, and you have your max. Because in the multiple choice, sometimes they'll ask you a question based on like, hey, which of these is the median, or which one is Q3? So you have to know the anatomy of this box plot here. Question 29, we have an expression for a and b, and we want to express a squared plus b in standard form. So for this one, a squared, we're just going to plug in for a, and we were told here a is equal to x plus 5. So we have x plus 5 squared, and then plus b is equal to x squared minus 18. So for this one, we have to be a little bit careful. Just make sure that you square this correctly. Please don't do something like this. Okay, this is a very, very, very common bear trap. When you want to expand this, you have to actually write this out as x plus 5 plus x plus 5. And the reason why I recommend you do that is that you actually distribute this correctly. So what a lot of students, once again, forget to do is they forget to do the first term times the last term, and then this term here times this term here. So most students, when they mess this up, do x squared plus 25, as you just saw. So you just have to make sure you actually distribute this correctly. So you have x times x is x squared, and then you have x times 5 is 5x. And then you distribute the 5, you have 5 times x, you get another 5x, and then you have 5 times 5 is 25. So once again, a lot of students, they'll miss this middle stuff here when they do mess this up. So you are going to have a middle 10x because you have x squared plus 5x plus 5x is 10x. And then you have plus 25. But remember, this part here just carries down. You have plus, and you could drop the parentheses because this is x squared minus 18 technically to the first, because this was b to the first. So we don't need parentheses when there's a 1 outside. You could just drop it and write x squared minus 18 like this. So we have plus x squared minus 18. So now we just combine like terms. We're going to have x squared plus x squared, and that's going to combine to, we're going to have 2x squared like this. And now for the x terms, there's only a single 10x term like this. So we don't have any like terms to combine with 10x. This is all on its own. But then we look here, we have 25 minus 18, and that combines to 7. So here's our solution, and our answer is in fact in standard form. Remember, standard form means we write the highest powers of x first, and then we write them in descending power order. So notice we have x squared, and then we have the invisible 1 here. So we have x to the first after, and then we have the constant term. So this would get us full credit. Question 30, we have the two relations shown below are not functions, and we want to explain how we could change each relation so that they become a function. So for relation 1, just looking at this fails the vertical line test at x equals 4. Notice when I draw on this vertical line, it hits the graph at 2 locations like this. So how can we fix that problem? Well, all we would have to do is open one of these points, or we could open both points. But let's say we open the graph here. So if we open the graph at 430, then this would pass the vertical line test, because when the vertical line passes through here, it's technically not hitting the graph if we have an open circle here. So that would fix relation 1. Now for relation 2, notice that the problem is we have repeating x values at -4. And if you think about this in the context of relation 1, if I plotted both of those points, if I had -4, 0 over here, and I had -4, 4, let's say up here, the vertical line would pass through both of those points. So there's a few ways that we could fix that problem. What we could do is we could just erase this point altogether. But if we wanted to do something a little bit different, let's say we didn't want to reduce the number of points here, we could change the point negative 4, 4 to something where we don't have one of these x values that showed up. So you could pick any value for x except negative 5, negative 4, negative 2, or negative 1. So let's say we move this to the location 0, 4. Now this is no longer a problem because if we had a 0 here, then none of the x's would repeat and this would not be a problem. Question 31, we have to factor this expression completely. And the first thing that jumps out at me is that each of these terms are divisible by 2. So why not factor out a 2 first? This is our greatest common factor. And when you're writing out the leftovers inside the parentheses, the math that I do in my head is I do each term divided by the greatest common factor. So I have 2x squared, and the greatest common factor was 2. So when we divide this by 2, we get just x squared. So that's what's going inside parentheses first. And then if we divide 16x by 2, that's going to give us 8x, and that's what I'm writing next. We have plus 8x. And then the last term here, we have negative 18. If we divide that by the greatest common factor 2, we're going to get negative 9, so we write minus 9. So this is our expression factored. But no, we have to be very, very, very careful here. This is a dangerous bear trap. Whenever you hear factor completely, that usually means you're going to have more work to do. So now we have to find two numbers that have a sum of 8, and the two numbers also have to have a product of negative 9. So this is going to factor even more to 2 times, and then we're going to break down this quadratic expression into 2 more factors like this. And since we're multiplying to a negative 9, that means that the factors are going to have opposite signs. It's going to be a plus and a minus. We're going to have x plus something and x minus something. So now think about the factors of negative 9. We could have something like 1 times negative 9. We could have 3 times negative 3. And the only other possibility here would be 9 times negative 1. But now think about each of these pairs, which of them add up to make 8. And the pair that you would want here would be 9 and negative 1, because if you did 9 plus negative 1, you would get positive 8. So we have x plus 9 and x minus 1 like this. So this would be our expression factored completely. Question 32, we're going to solve this equation algebraically for all values of d, and we're going to round to the nearest 10. So for this question, I'm thinking of the quadratic formula. And that's because we have something that's in the form of ax squared plus bx plus c is equal to 0. And anytime you have something in this form here, you could use this formula to find the solutions x. And in this case, the formula we're going to use is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, notice they use the letter d instead of the letter x, but we could still identify our a, b, and c value. So our a value is the coefficient of the square term, and that's going to be 3 here. And then our b value is the coefficient of the d term, which is negative 8. And then c, the constant, is 3. So just know that you use this formula when you're in the form ax squared plus bx plus c equals 0. If you're not set equal to 0, then you have to move everything to one side in order to use this formula. So now we just plug in, but instead of saying x equals, we have to say d equals. So we have d equals negative b, and notice that b is already negative. So we have to change the sign here. So negative 8, I could write it like this, negative 8, but just know negative 8 is positive 8. So we have 8 plus or minus the square root of, and then b is negative. Please make sure that you write this in parentheses like this, that you have negative 8 squared like this, because if you don't write parentheses, this is a dangerous bear trap. Okay, the calculator is going to read this as negative 64. So just make sure you're writing this with parentheses, because it will give you something different. That is the most common mistake with these questions. So negative 8 squared minus 4 times a is 3, and then c is equal to 3 like this. And we're dividing by 2 times a, so we have 2 times 3. Now, this is so important. I'm going to emphasize it once more. Just know when you get to the step where you have to write negative 8 squared, please make sure that you write parentheses, because if you don't, you're going to get negative 64. You have to write it like this in the calculator, and you should write it on your paper like this, because technically it's not the same meaning when you write it without parentheses. But when you write parentheses, you will correctly get the positive 64 that you need. So now to make sure that we're neat, I'm going to press alpha y equals enter, and that's going to pull up a fraction like this. And we have 8 plus or minus. So I'm going to do the plus first, and then I'll do the minus after. So we have 8 plus the square root of, and we could type this in all in one shot. We have parentheses negative 8 squared. I close the parentheses, and then I write my square, and then I have minus 4 times, And then parentheses mean multiply, so I could just write it with the parentheses like this. And the calculator will multiply all that stuff. And then on bottom, we'll pretend we don't know that 2 times 3 is 6. I'm just going to write it like this, and we press enter. And here's our first solution. And now for the second solution, remember, it's 8 plus or minus. So I'm going to press enter here just to save time. And now I scroll left till I get to the plus sign in front. And I'm going to change that plus to a minus. So that'll find me my 2 roots all at once. So now let's write out the 2 answers. We have d equals, and I'll simplify this a little bit. We're going to have 8 plus, and then under the square root, we have negative 8 squared is 64. And we're subtracting, we have 4 times 3 is 12, times 3 is 36. So we're doing 64 minus 36, which is 28. So we're going to have 28 under the radical. And then we're dividing by 2 times 3 is 6. And the 8 plus square root of 28 over 6 simplified to this here. And once again, we're rounding to the nearest tenth. So this works out. We look to the tens place. We look 1 to the right is a 1. So we round down to 2.2. So here's our first solution. And then our second solution, we're going to have 8 minus, and once again, the radical simplified to radical 28 over 6. And this one is going to simplify to, we look to the tens place is a 4, and then we look to the right is a 5. So we're going to round up in this case to 0.5. So here are the 2 solutions, and we can write it in one set like this in the squiggle or curly brackets. We have 2.2 comma 0.5. So here are the solutions to question 32. So now we move on to the part 3 questions, and these questions are worth 4 credits. Question 33, we're going to do 2 things. We're going to graph these functions here, and then we're going to use the graph to determine the values of x for which the functions are equal. So to get the graphs, we press y equals, and we have f of x is absolute value x plus 1. So we're going to press math, go to the right to number here, and then number 1 here is ABS for absolute value x. So we tack on the x, and then we hit the right arrow to get out of this, and then we write the plus 1 on the outside. And then for g of x, we have negative x squared, so negative x squared, and then we have plus 6x, and then last we have the plus 1. So now we could just press graph here to see what this thing looks like, but if we want to be really precise here, we're going to press second graph to get our table, and we're going to just copy and paste some of these values. So now that we have the table, we could plot these points and connect them accordingly. The absolute value graph is going to be in the shape of a V, and then this quadratic is going to be upside down. It's going to be frowning at us because it's a negative x squared. So now we're going to use the graph to determine the values of x for which the functions are equal. So we just have to look for the point of intersection here. So we have a point of intersection here and here. But remember, we're talking about the values of x. So that's going to happen here at x equals 0 and at x equals 5. And if we wanted to be 100% sure, just look at the table. At x equals 0, we have matching y values. And when x is equal to 5, we once again have matching y values. So I know these values of x are good. So our solutions, we have x equals 0 and x equals 5. And just know a few things here. I personally like to label the graphs here. We have f of x and g of x. And our table of values here does not have to be included for us to get full credit. So this would get us 4 out of 4. Question 34, we have Jean recorded temperatures over a 24-hour period one day in August in Syracuse, New York. And here's her results in this table. And her data is also modeled by this graph. And we have a few things to answer. But first, we're going to state the entire interval over which the temperature is increasing. So since we have a graph here where we're going forward in time and the temperature is modeled by the y-axis, if we want to find out the interval where the temperature is increasing, we're just really looking for when does the graph go up. Okay, so we're looking for when does the graph go up. Like this is what we're actually looking for. So looking at this here, we could see the graph goes up from here to here. So this is modeling when the temperature is increasing. In these sections over here, the temperature is decreasing because the graph is dropping. But now when you're identifying the interval, you're paying attention to the x-axis here. So we're looking here, it's starting out at 6, and it's going to stop increasing here at 12. So this would be our interval. We would be going from 6 to 12. And we could write our solution like this in brackets or in parentheses. This would get us full credit. So for the second part, we're going to state the 3-hour interval that has the greatest rate of change in temperature. So for this part here, how I'm breaking this down is when I hear the phrase rate of change, I'm thinking slope. And greatest rate of change, I'm thinking, when is this graph the steepest? When is it going up at the fastest rate? And I imagine if I had to climb this, it would be most difficult to climb here from 9 to 12. So that would be our solution to this part. So for the last part of the question, we're going to state the average rate of change from hour 12 to hour 24, and we're going to explain what it means in the context of the problem. So if we look here at the table from before, from hour 12 to hour 24 is corresponding to these points here. So I would write this out in point form. We have 12, 92, and we have 24, 74. And when we're finding the average rate of change, what we're looking for, the average rate of change, which I'll abbreviate like this, is the same thing as finding slope. So if I label this as x1, y1, and I label this as x2, y2, to find the average rate of change, which once again I'll abbreviate like this, it's equal to, we have the difference of the y values. So we have 74 minus 92 over the difference of the x values, we have 24 minus 12. Now, one thing I like to do, because when we have to interpret what it means in the context of the problem, is I actually like to write the units. So notice that 7492 was degrees Fahrenheit. So I'm going to write degrees Fahrenheit over here. Over the denominator, we're measuring time in hours. So I'm going to write the hours like this. And now we can find the average rate of change on the main screen. We press alpha y equals enter to pull up a blank fraction. And we had 74 minus 92. And we divided by 24 minus 12. So now we just press enter and we'll have our average rate of change. So the average rate of change is negative 1.5, and the units here are degrees Fahrenheit per hour. And the units really do help us interpret this, because this means that from 12 to 24, the temperature is decreasing 1.5 degrees Fahrenheit every hour. Question 35, we're going to graph this system of inequalities, and then we want to determine if this point is in the solution set, and we have to explain our answer. To graph both of these inequalities, I'm thinking of y equals mx plus b, because once we solve these for y, it's going to tell us the slope, the y-intercept, and it's also going to tell us which direction to shade. So let's say we take the first one here. We have 2x plus 3y is greater than or equal to negative 6. We're going to solve this for y. We could start by subtracting 2x on both sides, and this is going to cancel out on the left. And we've got 3y is greater than or equal to, we have negative 2x minus 6. And then we have to divide everything by 3. And that's going to give us this inequality here. We're going to have y is greater than or equal to, we have negative 2/3 x, and then we have minus 2. So here I'm noticing right away that our slope is negative 2/3 and our y-intercept is negative 2. So that tells me to start at negative 2 over here. So we're starting at negative 2. That's our y-intercept. And then our slope is negative 2/3. So that tells us how to get from one point to the next. So we're going to go down 2 and to the right 3, because the slope tells you the rise over the run. So let's go ahead and put this in quotes here. We have the rise over the run. So I could go down 1, 2 and over 1, 2, 3 like this. And I could just keep doing that, going down 2 over 1, 2, 3. And then if I want to go backwards, I'm going to go up 2 and to the left 3 like this. And notice that these points here are forming a straight line. So we're going up 2 to the left 1, 2, 3 like this. And now we're going to connect these points with a solid line. Now, the reason why we're going solid here is because we have a greater than or equal to. And since we have a greater than or equal to, we're going to shade above this line like this. So we're going to shade up. So this gets us started here. Now, one thing I recommend that you do for this is make sure that you label at least one of these inequalities on the graph here. So since we started off here with 2x plus 3y is greater than or equal to 6, I'm just going to go ahead and label this as 2x plus 3y is greater than or equal to 6, or I'm sorry, negative 6. So we have greater than or equal to negative 6 like this. Okay, if you don't label this, this is something that they could take off points. So now for the next inequality, we're looking at, we have x is less than 3y plus 6. And for this one, I want to get the y on the left and the x on the right. So I'm going to do minus 3y, and we're going to have minus 3y on this side like this. So we have minus 3y and we have plus x, and now we have is less than 3y minus 3y cancels, and we have 6 over here. And now we can subtract x on both sides like this, and that's going to cancel out on the left, and we have negative 3y is less than negative x plus 6. And now divide everything by negative 3. But one thing to be careful of here is we're dividing by a negative. So just know with inequalities, anytime you divide or multiply both sides by a negative, the sign is going to flip. So now it becomes y is greater than, and now we have negative, think of this as negative 1x over negative 3. We'll change to positive 1 over 3 times x. And then we have 6 divided by negative 3 is negative 2. So now for our second inequality, we have a slope of 1/3 and we have a y-intercept. So we have a y-intercept here. Let's make that a little bit neater. So we have a y-intercept of negative 2. So we're going to start here at negative 2, but now we're going to go up 1 to the right 3, because we're rising 1 and we're running 3. So we're going up 1 and going over 1, 2, 3 like this. So we just keep doing this here until we get a few points. And remember, if I want to go backwards, I'm just going to go a little bit opposite. Instead of going up 1 over 3, I'm going to go down 1 to the left 3 like this. And remember, since these are linear inequalities, these points should be forming a straight line. So we go like this, but now one thing we have to be careful of is for this one, we have to connect these with a dotted line because it's just greater than here. So let's go ahead and do that. Okay, and we don't have to label this second inequality here, but I will anyway. We're just going to call this here, we have x is less than 3y plus 6. But remember, we still have to shade, and right now we have y is greater than 1/3 x minus 2. So that means we have to shade above like this. So we're going to be shading above this blue line like this. And now once we have this all shaded, remember there's one very, very, very important detail here. They told us to label the solution set with an S. So I'm just going to write an S in this space over here where the shaded sections overlap. So we're going to put an S here like this, nice and clear. And just note, if you don't write this S in for this particular test, they will take off a point. And if you do everything else correct, you'll get a 3 out of 4. But that's so devastating just for leaving out this letter here that you don't get full credit. But just make sure you read everything. So this would get us full credit for the graph. So now to answer the question, is the point 4, -2 in the solution set? So now we go to the origin. We're going over 1, 2, 3, 4, and down 2. And notice here that this point is a solution to 2x plus 3y is greater than or equal to -6, but it's not a solution to the one in blue here. It is not going to satisfy x is less than 3y plus 6. So right away, I'm going to say no. And the explanation here is that it does not satisfy both inequalities. So the graph really helps us here to show that this is not a solution to the system. And just to verify here, when I write my sentence, I like to just show here that it does not satisfy the one, in this case here in blue, that x less than 3y plus 6 is not satisfied by this point because it gives us this statement here, 4 is less than 0, which is simply not true. This would get us full credit. Question 36, we have Susanna collecting information about ponies and horses, and we have a table here showing the relationship between height and weight, and we have these 3 questions to answer. So the first thing we want to do is write the linear regression equation for this set of data, and we're going to round to the nearest hundredth. So for this part, we're going to press Stat and go to Edit here, and we're going to enter this data in the L1 and L2 column. Now, once we have all the data entered, we're going to press Stat and go over to Calculate, and we want a linear regression. That's option 4. So we press 4 here, and we press Enter a whole bunch, and here's all the information that we need for the first part. Now, one thing we could do all in one shot is later on we're going to have to find the correlation coefficient, and right now it's not being shown, and that's because we have to switch the diagnostic on. So I'm going to press second and then 0 here for the catalog, and I could scroll down to the letter D, or I could press alpha and then this x -1 button, because that's where the letter D is located like this. So I press alpha, and then let me just press this correctly. We have alpha and then x -1 here, and that brings us to the letter D, and we're going to go down to diagnostic on. So we go ahead and press this, and now what that allows us to do is the next time I do the linear regression, so I'm going to calculate here, linear regression is option 4, is now it's going to include all the stuff that we need for the later parts here. It's going to give us the R value, the correlation coefficient. So now we can write out the answer here. We have A equals, and A was equal to, we have 184 point, and we look here, we have a 9 in the hundredths place, and we're rounding to the nearest hundred, so we look to the right as a 2. So we're going to round down to 0.89 like this. And then for our B value, we have -1706 point, and then we have 071 like this. So we look at the 7 in the hundredths place, and to the right is a 1. So we're going to round down to 1706.07, and we have the negative in front like this. So now our equation is just y equals, A is our slope, so that's 184.89 times x. And then we have our B value is -1706.07 like this. So here is our linear regression equation. For the second part, we're going to state the correlation coefficient for this linear regression, and we're going to round to the nearest hundredth. So we look at the R value here, that's our correlation coefficient, and we look to the hundredths place is an 8, and to the right is a 5. So we're going to round this up. We're going to say R equals 0.99 like this. So now for the last part here, we have to explain what the correlation coefficient indicates about the linear fit of data in the context of the problem. So for this one here, remember, we're talking about the weight and height of ponies and horses. So if we look here, we have a strong positive correlation. And how I know this is that when you're thinking about your correlation coefficient, it's either going to be between -1 and 1. And if it's close to either of these endpoints here, that means strong. So R equals 0.99 is pretty close to 1. So that would be a strong positive correlation between the height and weight of ponies and horses. So what that's saying in the context of the question here is that the taller a horse or a pony is, the heavier it is going to be. So we move on to part 4, and this question is worth 6 credits. So question 37, we have Dana shopping for plants, and she bought 3 roses and 2 daisies, and that cost $31.88. And then later that day, she went back and bought 2 roses and 1 daisy for $18.92. And we have R represents the cost of 1 rose, and D represents the cost of 1 daisy. First, we have to write a system of equations that models this situation. So looking at this, we have 3 roses plus 2 daisies, and that's going to cost $31.88. So this is our first equation like this. And then the second equation we could set up is the total bill for later that day, that Dana went and bought 2 roses and 1 daisy, so just plus 1D or just plus D, and this cost $18.92. So this would be our system of equations. For the second part here, we're going to solve this system of equations, and we're going to solve it algebraically. That's going to tell us the cost of 1 rose and 1 daisy. So we have 3R plus 2D equals $31.88, and then our second equation, we have 2R plus D is equal to $18.92. So just looking at this system here, I want to use elimination, and I think it's going to be easier here to eliminate the variable D. So that we could do by multiplying the bottom equation by -2. And what that accomplishes is we have 3R plus 2D equals $31.88. And now for this next part, we multiply everything here by -2. And we're going to have -4R when we do -2 times 2R. We're going to have minus 2D, and then we're going to multiply $18.92 by -2. And this is going to give us, we're going to have -37.84. Okay, so we just multiplied everything here by -2. And now what we could do is we could take this resulting system and we could add it together like this. And we're going to have 3R plus -4R is -R. And then 2D plus -2D eliminates like this. And now we just have to do 31.88 minus 37.84. And that's going to work out, we're going to have -596 like this. So this is -R equals, and we have -596. So we could just divide this by -1, and this tells us the cost of 1 rose. So after these cancel out like this, we're going to have R equals 596. So now we could take the value for R here, and we could plug it into any of these equations, but I think it's going to be easiest here to plug it into this one because the numbers are the smallest here. So we have 2 times R is 596, we have 596 going here, plus D equals, we have 1892. So 2 times 596 is going to give us 1192. So we have 1192 plus D equals, we have 1892. And now for this part, we just subtract. So we have minus 1192 on both sides. And for this, we could just go ahead and cancel out. And we have D equals 2 minus 2 is 0, 9 minus 9 is 0. We throw on our decimal, 8 minus 1 is 7, and then 1 minus 1 just goes away. So the cost of the daisy is $7. The cost of the rose is $5.96. Now, before we move on, the question actually asked us to determine the cost. So I want to write this out in money form. So now for the last part of this question, we have if Dana had waited until the plants were on sale, she would have paid $4.50 for each rose and $6.50 for each daisy. And we have to determine the total amount of money she would have saved by buying all of her flowers during the sale. So let's think about the total bill. And to answer this part here, I'm going to borrow the information that we had in the previous part of this question. So when we wrote our system out, it modeled the 2 trips that Dana took to the store here. So she bought some flowers for $31.88, and then she bought more flowers for $18.92. So if we add these together, this will tell us how much Dana spent in total. So if we add these together, this works out to $50.80. So this tells us that Dana spent $50.80. But now if we add the system together, let's think about what this means. We have 3R plus 2R is 5R, and then we have 2D plus 1D is 3D. And this is equal to 50.80. So this tells us that Dana bought 5 roses and 3 daisies in total and spent $50.80. But remember, the goal here is to determine the total amount of money that she would have saved by buying all of her flowers during the sale. So now let's think about the sale. If she had bought all of these flowers during the sale, that would be 5 roses for $4.50 each. So if we do $4.50 times 5, this is going to tell us how much it would cost to buy the roses. So this one we could just work out. 5 times 0 is 0. 5 times 5 is 25, and we carry the 2. And then we get 20 plus 2 is 22. So it would be $22.50 for the roses during the sale. And now let's think about the daisies. The daisies are $6.50 each, and Dana bought 3 total. So that would be $6.50 times 3. So if we work this out, we have 3 times 0 is 0. 3 times 5 is 15. We carry the 1, and then we multiply. We get 18 plus 1 is 19. So this would be how much she would spend on Daisy. So if we add these two together, that's $22.50 plus $19.50. This tells us how much she would have spent during the sale. So this will give us 0 when we add. 5 plus 5 is 10. Carry the 1, that gives us 12. Carry the 1, and we get $42 exactly. So now we could take the total bill here and then how much she would have paid during the sale, and we want to find the difference. So we're just going to subtract. We have 50, 80, and we're subtracting 42 like this. And this we could just subtract ourselves. We have 0 minus 0, 8 minus 0 is 8. And then here we're doing 50 minus 42 is 8. So she would have saved $8.80.